Good morning students. Today we discussed about the counters. Counter is a device which stores number of times a particular event or process has occurred, often in relation to a clock signal. So counter is a device which stores number of times a particular event or process occurred. Now we discuss the binary counters. Binary counters broadly divided into two types. One is the asynchronous binary counter, one is the synchronous binary counter. Already we know that asynchronous sequential circuits, synchronous sequential circuits. Asynchronous sequential circuit is nothing but all circuit elements runs with the different clock signals. Synchronous sequential circuit is nothing but all circuit elements runs with the same clock signal. So in this also same asynchronous counter is nothing but it is also known as ripple counter. Different flip-flops are triggered with the different clocks, not simultaneously. That means asynchronous counters all circuit elements runs with the different clock pulses. That is the asynchronous counter. And next one is synchronous counter. In synchronous counters, all flip-flops are triggered with the same clock simultaneously. That means synchronous counter, all circuit elements runs with the same clock simultaneously. So last video asynchronous counter is completed. Now we discuss the synchronous counter. So in this video we design the 4-bit synchronous counter. To design 4-bit synchronous counter we use 4 JK flip-flops. So in this common clock triggered all flip-flops simultaneously. That means 4-bit synchronous counter, all circuit elements runs with the same clock. So this 4-bit synchronous counter counts 0 to 15. 15 counts, that means 0 0 0 0 to 1 1 1 1 up to 15. It counts up to 15. So now we see the diagram of synchronous 4-bit synchronous counter. So this is the 4-bit synchronous counter. In this we use 4 JK flip-flops. This is the JK flip-flop 1, JK flip-flop 2, JK flip-flop 3, JK flip-flop 4. In this every flip-flop J and K is the inputs, Q and Q bar is the outputs. So if inputs J and K is equal to 0, the flip-flop does not change the state. That means it carries the previous state output. If J, K is equal to 1, flip-flop complements. That means J is equal to 1 and K is equal to 1. Flip-flop goes to toggle state. Toggle state means we get complemented previous output. Suppose previous output is 0, so next state output is 1. Previous output is 1, next state output is 0. So we get complemented previous output. That is 0 becomes to 1, 1 becomes to 0. So counter uses positive or negative edge triggering clock pulses. In this counter we use negative edge trigger clock pulse. That's why at every negative edge trigger clock pulse, flip-flop change their state. Change their state means change their output. At every negative edge flip-flop change their output. This is the negative edge clock pulse, indication of negative edge. This arrow mark is indication of negative edge. This is the positive edge trigger clock pulse. This is the indication of positive edge. This arrow mark indicates the positive edge. Now we see synchronous counter diagram. So in this first flip-flop output Q0 is connected to second flip-flop inputs J and K. In this we use two AND gates, AND gate 1, AND gate 2. AND gate 1 output is connected to third flip-flop inputs J and K. AND gate 2 output is connected to fourth flip-flop inputs J and K. So AND gate 1 is equal to the product of Q1 and Q0. Q1 and Q0 are the previous outputs. So AND gate 2 is the product of Q2 and Q1 and Q0. Q2 and Q1 and Q0. This is the product of Q2 and Q1 and Q0. These are the previous outputs of the flip-flops. So in this first flip-flop JK always connected to VCC, always connected to VCC. So VCC is nothing but J is equal to 1 and K is equal to 1. So if J is equal to 1, K is equal to 1, so first flip-flop toggles on every clock pulse, toggles on every clock pulse. So toggle state means first flip-flop toggle state on every clock pulse. Toggle state means we get complemented previous output, complemented previous output. So and next second flip-flop, this flip-flop toggles only if the Q0 is high. So this Q0 is connected to input of the second flip-flop. So first flip-flop output to Q0 is high, automatically second flip-flop inputs J and K is equal to high, that is equal J is equal to 1, K is equal to 1. J is equal to 1, K is equal to 1, flip-flop goes to toggle state. And third flip-flop, this flip-flop toggles only if Q0 and Q1 are high. So the third flip-flop inputs J and K. These J and K is connected to AND gate output, AND gate output, AND gate 1 output, AND gate 1 inputs Q1 and Q0. Q1 and Q0 is high, automatically AND gate output is high. AND gate output is high, J is equal to 1 and K is equal to 1. This flip-flop goes to toggle state. And this flip-flop goes to toggle state only if Q0 and Q1 and Q2 are high. Fourth flip-flop input is connected to output of the second AND gate. Second AND gate inputs Q2 is high and Q1 is high, Q0 is high. Automatically second AND gate output is we getting high. So second AND gate output is directly connected to fourth flip-flop inputs JK. So J is equal to 1 and K is equal to 1. So in that situation, this flip-flop goes to toggle state. This flip-flop goes to toggle state. Already we know if inputs J is equal to K is equal to 1, flip-flop goes to toggle state. So that means 0 becomes to 1 and 1 becomes to 0. So and if J is equal to and K is equal to 0, flip-flop does not change state. It carries the previous output value. This is the total concept of synchronous 4-bit synchronous counter.